This right here is a Victron Energy Blue Power Quattro, and this is the 48 volt 10 kVA model, and this is an inverter charger. They do make this Quattro in other configurations, like smaller VAs, different voltages here, but you know, the biggest difference between this Quattro and a MultiPlus 2, which is also popular, is one, the Quattros usually have 2 AC inputs, and then 2, the Quattro usually always have a higher volt amperes rating, or the capability or power output rating. That's not the only thing that differentiates them, but those are the 2 major things that everybody kind of accepts and takes away from it, right? So this is the nicest inverter I think that we've ever had the privilege to use and work with. And if you have the possibility to go work with one, use one, see one, touch one, I would highly recommend you go do that, mainly because it's one of the nicest inverters I think I've used, and you will be working with it thinking, wow, they did a really good job with this. Obviously, you know, if it's not yours, don't touch it. If it's on, you know, touch with caution or don't touch it at all. Anyways, point is, we're going to go over this inverter top to bottom and go over some of the stuff it can do. Not everything, because that video would be like 8 hours, but we'll go over some of the basic features of it and how we plan to use more of it in the future. So if you want to know more about this Quattro, stick with us. First things first, let's go over some of the specs. First of all, like the Quattro, this has a 2 AC input system with an integrated transfer switch. Some people would call that just using a relay, but pretty much the 2 AC inputs work, and then it has pretty much a no-brick functionality for the main output so that the inverter can really take over in less than 20 milliseconds. That means all the computers and stuff like that, you know, will work perfectly like sensitive electronics. You can put 2 units in split phase, or you can put 3 units in 3-phase output, but you can also parallel many of them to get up to 120 kVA of inverter power. That's right, that's 120,000 volt amperes of inverter power and more than 1,600 amps of charging capacity. So that is obviously going to be a lot if you had, you know, that much, but if you're doing that much energy, you're consuming or whatever, that much energy, you probably already know what you're doing. So it has other capabilities like power control, which, you know, deal with the limited AC that's going to be coming in. We'll talk a little bit more about that later, but there's power assist, and obviously with the inverter charger systems like this with Victron, you don't have an MPPT or a charge controller, so you will have to get that one separately. All the on-site or remote monitoring stuff are going to have to be done through either the Victron Connect or the VE bus or some type of VRM type device. We have a Cerbo connected. We'll talk about that in just a little bit. But now let's get to the actual specs. So this model, which is the 10,000 kVA model, has 2 AC inputs, and it has a maximum feed-through current of about 100 amps. The continuous output at 25 degrees Celsius is obviously rated at 10 kVA, which is kind of how they, you know, name these inverters or spec these inverters. But if you want to convert that into watts, that's 8,000 watts of continuous output. If you get a little bit warmer and you're working at 40 degrees Celsius, that's about 6,500 watts of continuous output. And then at 65 degrees Celsius, it drops down to about 4,500 watts of continuous output. And this is, like almost all Victron inverter charger systems, is a low-frequency transformer-based inverter. And due to that, it can take a maximum peak power, or high peak power, I mean. And the maximum peak power this thing can put out is about 20,000 watts. That's right, 20,000 watts. Not 2,000, but 20,000. The maximum efficiency on the system like this, you're going to get about 96%. And if you're talking about idle consumption, that's going to be somewhere around 60 watts. If you put it in like AES mode, that's about 40 watts. Or if you want to put it in search mode, also known as eco mode, you would get about 15 watts of idle consumption. Obviously, would not recommend that, mainly because, you know, it has some quirks to it, but if you want to use that, you know, go for it. The auxiliary output is rated at about 50 amps, and this thing uses the bolt system. So if you wanted to install the terminals and stuff like that, instead of like a spring or a screw down type system, it uses the bolt system, and those bolts are M6. And this thing is not light by any means. It weighs a whopping 128 pounds or 58 kilograms, And the dimensions, as you saw in the video earlier, it's actually pretty big. It's about 22.6 by 19.2 by 13.6 inches. So, you know, that's actually pretty big. It's got a lot of the anti-islanding other features and stuff like that built into it, depending on the model you get and the area that you get it from. So depending on if you need that kind of stuff or not, go look at the website for wherever you're buying it from in the region that you're getting it from, because depending on which ones you get, it may or may not have that feature. First, let's talk about installation, and I will go ahead and say installation is no joke. As you can see, we have the super strut kind of going this way, and then the way that this system works is kind of like most Victron systems, and there's like a bracket that you install. If you use MultiPlus systems, you know, you install the bracket, then you put it on top of the bracket. This has a bracket, a big bracket, obviously, considering how heavy it is, and there's a metal piece that sticks out. So you want to lift it, put it on there, and then screw it down so it doesn't really come off. In our situation, we've installed the bracket on the super strut there, and then we've installed this into place, and that was no easy task. If you have a tool to help you do that, I would highly recommend that, especially because you're going to be putting yourself in danger just trying to get that on there, and it was, you know, not easy by any means. Front of the inverter has pretty much this graphic drawing that kind of tells you how everything's connected with the relays and stuff like that. Obviously, 48 volt, 10,000 kV or 10,000 VA. 140 amp pass through and charging you can really get with some of this. The transfer capacity is actually listed here, so this is really technically the charging capacity. So the charging specs are listed here, you know, depending on which phase of the charge cycle you're in, and then the inverter parts listed here. If you look at the Cerbo GX or the screen, and you kind of see the dots on there, those dots are actually exactly what's going on here. And we'll go ahead and take a look at that a little bit later. But you can go ahead and get the front of this off by taking off the 4 screws, which obviously we've done. So we'll remove that. And then once you remove those screws, you can really get in there and then look at the connections. So here we have the inside of the inverter charger, and this is safe to touch mainly because this has been off for a while and, you know, all the energy has been discharged. But I would not recommend touching any of this in any situation. I just know that this has been off, right? So here is the AC 1 in, the ground connection is here. The AC 2 in, ground connection is here. AC 1 out, ground connection here, which is shared between AC 2 in and AC 1 out. AC2 out is right here. So the AC2 out, the ground connection is here. And as you mentioned earlier, if you're used to other, you know, high frequency inverters that have these screw down terminals, this is the bolt type terminals. So the main big difference between working with it is that when you install this type of system, you really need to get the rings terminals so that you can terminate the cables with the ring terminals and then screw them down. Because on the other screw down terminals, you can either put ferrules on them or some type of sleeve on them such that, you know, the wires don't go everywhere. But in this system, ring terminals. There's obviously a lot of this stuff has been glued down to prevent any vibration stuff if you were to install this in some type of vibration system. So that's obviously really nice to see. And here we have the battery connection, obviously the screw down lugs, and here this right here is installed with two 2-aught cables, negatives here, positives here. This white cable is the VE bus connected. We'll take a look at that shortly, or I'll just throw up a picture of where it is, which is right here. But the other thing I'll point out, which obviously you can see here, is that it's very interesting how they decided to put the other terminals back here. Like for instance, if you wanted to use the ground relay terminal, which is actually this one right here, or the V-Sense terminal, which is actually this right here, it's going to be pretty difficult to get to, mainly because the battery cables are going to be blocking them. So yeah, I'm not sure why they decided to do that the way that they did, but I imagine that's going to be frustrating for many people, not only just to get the wire there, but imagine doing like wire management there. So, you know, I would, you know, maybe consider that, or maybe routing the battery cables in some different manner or something if you needed to use those terminals, because the battery cables are going to be blocking your access to there. Want to show you the bottom of the inverter charger here real quick, and as you can see right there, that right there is the bracket, the bottom part of the bracket that it sits on. It's got 3 big fans, 1, 2, 3, and it actually blows air upwards through the transformer and all the other stuff that's in there, and it's nowhere nearly as much stuff as a high frequency inverter, and then it comes out the top. We'll go ahead and take a look at that in a little bit, but the 3 fans are actually pretty quiet, so when you run this thing at load, you won't actually be hearing that many fans. You'll actually probably be hearing more of like the low frequency hum or buzz from the transformer, but that's there. To ground the inverter, the grounding is lug is right there, and you definitely want to make sure that gets grounded. All right, so coming around to the top here, you can see it's designed, you can use this part as a handle if you need to, but if you're going to lift from here, I would highly recommend using gloves because this part here is a metal edge. As you can see right here, the grate system is here such that the air can flow through and come out. So the air flows from bottom up and then also comes out here. So make sure you leave clearance for this stuff when you mount this thing, mainly because you do want to be able to breathe. It doesn't move a lot of air in high velocity, but it does move a good amount of air, and the good thing is that it's silent. So let's talk about some of the connections we have going on here real quick, and we have just a basic connection so that we can kind of demo and do a little bit of a load test on here, right? So the obviously right here you have two 2-aught cables connected to the battery lugs here. The red cables are two 2-aught cables, also they're positive, so they're connected right there. This white cable here is the VE bus connection, and it's a standard Ethernet cable. There is nothing special, no special pin outs or anything like that. Standard Ethernet cable that connects to one of the ports, any one of the ports, there's two here, that connects to one of that, and it connects down here to the Cerbo GX down there. And here we have, I believe it's 6-gauge Romex here. The black is hot and the white is neutral, and then you got this ground wire here. That comes obviously back through here into this load center right here. And this load center, we'll talk about that in just a little bit here, but that's where the power is going to be going out of there. If you wanted AC in, you could connect AC in, put it in here, and that way you could charge it and use this to charge the system. We actually don't have that right now because the battery's already been fully charged so many times. Don't need to worry about that. So with that here, let's go ahead and talk about this battery box. This battery box is the first generation indoor wall mount conduit box for this battery. If yours looks different, or if the one on the website looks different, I would say it's because you probably have a later generation of this, whereas I had the first generation one. So the first generation one, you open it up and it looks like this. The battery cables come down here, and they have a quick connect type system. It's a Dexon system, so you just push it on and it connects. There's 4 connection points here on a bus bar. I think it's like a 600 or 400 amp rated bus bar, but that's pretty fine there. The positive ones also have the same bus bar system, so you connect there, no problem. The system ground, the bare copper wire that you saw earlier that was installed to the lug that was back there, actually comes down here and connects to this grounding lug right here, which connects pretty much all the metal pieces. The battery, this conduit box, which is metal, and the frame of this, right? All the metal pieces are connected to one point here. And even this door, which is metal, is still connected with this cable here. So that's how that works in there. There's a little bit more of a mess because, we had to rearrange for different projects. But it's got this blue Ethernet cable here, which connects from the CAN port of this EG4 indoor wall mount battery to this Cerbo GX. And it is not your standard Ethernet cable. We have a video on how to make that custom cable in case you need to do that, or you can just pick it up or buy it if you need to do that too. But this right here is the EG4 wall mount indoor battery. It's like a 14.8, I think, kilowatt hour battery. Wall mount, and this battery, I believe, as you can see, I think is actually perfect for this system because you have it mounted to the wall with the conduit box, and all the cables can kind of go, short-handed here. I didn't want to punch additional holes in here, so like I said, I've already used this battery and this system for the 6000 XP and other inverters. So if you're only installing something one time permanently, obviously you can just punch out the holes, right, and make it, bridge this gap closer. But in our case, since we've kind of changed out systems and stuff like that, it looks a little bit messy here, but you can obviously decrease that gap. So this right here is a load center. Right here is a 6-gauge cable coming in through here, and like I said, everything's off, so it's safe to touch, but I would highly recommend you do not touch. So this Romex cable comes in here. This black one goes to this 50 amp breaker, which is actually great for this inverter. And then the white one connects to this neutral bar. So if you don't know what neutral bar is, it's this bar that kind of goes all the way around. And then the ground cable is connected to this ground bar here. In a lot of cases, if you pick up a load center, the ground bars don't come with them. You do have to pick them up separately. So if you're picking this up at your home center, make sure you pick up the ground bars for your perspective panel, okay? Also in here, we have the ground neutral bond, which is plugged right here, that green screw, which bonds this frame to this neutral bar, right? And then because the frame is also connected to these ground bars, these ground bars are now technically bonded at this point. And that's what you really want, because in any electrical system type like this, you really want one point of ground, and that's how this is set up. So the power comes in, feeds through this breaker, and right now, because we only have one, only this bar right here, or this lineup, is energized. So the power comes in here, it feeds this bar, and this entire thing right here is energized. You could technically also pull power by putting a breaker here, because it'll connect to this point here. But I'm just going to be using this for now for this demonstration. This breaker right here is a 20 amp breaker connected to this yellow Romex. So the yellow Romex, I think is, was it like 12 gauge? The 12 gauge Romex, and the black is hot here. Obviously the ground and the neutral are connected here. And this right now will feed this GFCI outlet right here. And I do apologize for the mess. I'm sure someone's going to point out not everything's done to code, but you know, this right here is only set up for this demonstration and not to be installed here long time or permanently. And you know, we're always moving these components around. So anyways, that's how this is connected. So we'll go ahead and flip the power to this to make it come on. And the way that I've been doing that is to be able to go ahead and turn this here to off position. That way the inverter itself is off. We'll go ahead and flip the breaker to the battery that's there, so that way when the BMS powers on and it goes through its pre-charge cycle, it'll go ahead and slowly feed the power into here, and then everything will be live. So after we turn it on, don't touch anything. All right, obviously we'll have to flip the breaker and stuff like that, so I'll just go ahead and do that now so I don't have to even reach in here as we do this. So here we'll flip that breaker on, we'll flip that breaker on, and we'll go ahead and flip the BMS or power button to the battery. The battery's gone through its pre-charge cycle. We'll go ahead over here and then turn on the switch to on. So if you switch it to on, it'll be in charger and inverter mode. If you want to not use inverter mode and only charge, you flip the switch down and it goes to charger only mode. So go ahead here, turn the switch to on. There you go. As you can hear, it's kind of got that low frequency buzz. I'll get the mic closer up there to see if you can hear it. So hopefully you can hear that. It's got that low frequency buzz, and as you can see right here, the green light here comes on saying the inverter is on. So this demonstration obviously is not going to be drawing peak power from here, mainly because we only have one of these connected. I guess technically I could connect the other one here to draw more power, but if it works, okay? So right now you can see power is going to be feeding into the main panel, or this panel, which is going to be used as the main panel, to this breaker here, and this breaker here is feed power coming out. You probably can't see it too well right there, especially due to the lighting, but this green light here is on, and because you can't see it that well, we'll go ahead and take this outlet tester, stick it in here. Tamper resistant outlets, as you can see right there. The two LEDs here are on, and if you look at the configuration here, it says it's technically correct. So we'll go ahead and get a load connected here. That way we can draw some power. As the heater's getting warmed up, let's take a look at this battery. If you haven't seen this battery, there's tons of videos on this battery. We also have one too. So if you want to check it out, go check it out. But as you can see here, assuming you can read it, it says discharging right here. We're discharging right now about 30.5 amps. That's the voltage of the battery. And right here, I set the CAN port to be P06 VCT, which is the setting that you need to connect the CAN bus over there port to the Cerbo GX here. And since we didn't get a chance to look at the Cerbo GX too much earlier, let's go take a look at that, which is this guy right here, which is the monitoring brains of this system. So we'll bring you in just a little bit closer. And as you can see right here, Cerbo GX, this is the power cable for this. We're actually just powering this off with just some battery here. But this is the BMS connection. That's the port right there back in the back. And this white cable is the one that's connected to the Quattro here. And this is the HDMI cable with the Ethernet plug right here connected to the screen. The screen you do have to buy separately. We have the Touch 50. And this right here is a Touch 50 from that HDMI cable. So this red box is the grid connection, and obviously we don't have any AC connected in. So you're gonna see nothing right there. This is obviously is the inverter that you have. If you have multiple inverters, it's gonna be like, you know, a collection of inverters. Right now we only have the one connected here. And then this right here is your AC load. So technically this should be the breaker box or the main panel. And this right here is the EG4 indoor wall mount battery. And as you can see right there, even tells you the wattage, the voltage, and the amps coming out of it. As I mentioned earlier in the beginning, you see the dots right here. The dots right there are reflective of the LEDs that are on front of the Victron inverter. And I'm really glad that, you know, Victron did this, mainly because if you have the inverter charger tucked away somewhere, you can't really see it. But if you look at it here, you can see it without looking directly at it. So that's working great here. There's another view. You can look at it this way. Or you can just go back and look at it this way. Or since you have other sections connected like BMS EG4LO battery here, this stuff here, if you get the communications working, all the great features come out in here. And that's why I would recommend if you're gonna use or build a system like this, I would get the EG4 indoor wall mounted battery because I know that the communication works fine. And it also, like I said, profile-wise, it fits almost perfectly with the battery. Anyways, point is, you get the EG4LO battery here, Quattro, it's in a state of inverting. You can go and see, you know, all the other specs in here. We don't need to go too much detail into that. You can go look at the battery voltage, state of charge, temperature, devices, alarms, parameters, all that kind of stuff in case you wanted to check that. Other settings in here of like, you know, this other system, date time console, remote system, ESS portal, all that kind of stuff. So there is an app and you can connect to the app to look at it, or you can also just go to the VRM portal online if you've connected your Cerbo GX to the internet, and it'll push, you know, online stats there, and you can go manage your system from there. But in this case, the point is that everything really works well right here, mainly because you can look at it right here, and the heater right now is drawing about 1,400 watts, which is actually really low for this inverter, because this inverter is capable of putting out about 8,000 watts continuous. So as I mentioned earlier, you can fill out the load panel to pull more power, but in our case, our use case wasn't exactly to power a bunch of circuits, but mainly even to charge an electric vehicle. That's the basics of this Quattro, and we didn't get too heavily into any of the other advanced features, right? Because it can do things like power assist, which means if you have AC connected and you're drawing more power from it, what it will do is, if you only have 10 amps of AC input capability and you're drawing 20, the other 10 will be supplemented from the battery sources to supply that output, right? So you're gonna be thinking, oh, well, what situation would you need something like this? If you have an RV and you go to an RV park and they only give you 15 amp outlet, 20 amp outlet, 30 amp outlet, but you need 50 amps to run, I don't know, I'm making up your stuff, your air conditioner unit and all your other microwaves and blenders and stuff, then this unit would be perfect for that because it can do power assist. You know, other devices can do that, like the MultiPlus 2s and stuff like that, but that's pretty much what PowerAssist does. It's also got the automatic switchover, like I said earlier, so if AC1 goes down, you know, AC1 output here will just continuously be powering it. So it's got the relays or the transfer switch built in such that when the power goes out, it'll automatically switch over. So if you have AC2 here, I'm not gonna touch anything because it's, you know, still connected or on, is that AC2, for instance, is a hot another port you could use in case you wanted to have things not be powered if you weren't plugged in to AC source, or you can just configure to program it all differently. So it's got an unlimited number of ways you can kind of do that. But the most typical way people would use AC2 is that if you have something, let's say your AC, your air conditioner unit, and then you don't want that to be working if you're not plugged in the mains power, grid power, store power, then you would connect it to AC2 so that you're not draining a ton of your energy from your batteries, and you can use AC1 for lights or other stuff. People will argue air conditioners are a necessity, so you know that situation, for example, may not be perfect, but that's really how that would work Also, as you can tell right now, only thing you're really getting is a low frequency hum. So if you want to install this in an indoor, more, inside an RV type situation when you can hear stuff, that could be annoying. Maybe something to consider in case, that's something that you're doing. But if you're installing it in a remote place, that's not going to be a problem whatsoever. So we actually purchased this unit from Signature Solar. We actually did purchase 2 of them, and all the other stuff that you see here, I mean, obviously besides the load center. And if you want to pick up something like this, I would highly recommend you go check that out, especially when they do like free shipping promotions and stuff like that. You can get a lot of the freight shipping for free, and this unit is really heavy, so it's going to be shipped freight. All right, so the only reason I'm telling you that right now is because we've already purchased the 2 units that do that, and we're just going to go about this in a series of getting it there, mainly because there's so much these inverters can do, it would just not do it justice, right? So this is here. My ideal situation is to have another one of these indoor wall mount batteries right next to here and have them 2 side by side. I just don't know if I can make that happen. But the idea is that eventually you want to get a second one of these, configure it in split phase, and then power the load center. That way you get 240 in the load center, and then you could do pretty much almost anything. Mainly because this one here only does a single phase out, so it's going to give you about 10,000 VA at single phase 120. So if you think about that, that's a lot of amps, all right? So make sure when you're dealing with any of this, be careful. Don't, check yourself or do any of that stuff. But hopefully this video helped you guys out. So if you have any questions, let us know. Have a great day, get back to work, and we'll see you guys next time.